welcome to CEC lectures. Myself Dr. Preeti Chagwani. I am from Department of Computer Science, Arabhat College, University of Delhi. Presently, we are learning the series of operating system concepts, and in the previous lecture, we have seen the concept of threads, and today's topic is about process synchronization. So, first of all, let us try to understand what actually process synchronization is, what is the need of process synchronization, and how it is, connected to the topic of thread. So, basically, why we have put in up this process synchronization concept here just after the thread. So, there is a kind of logical reason behind it. Let's try to explore process synchronization first. So, operating system, as you all are aware, that it is basically software which acts as the resource manager. Whatever resources a computer system is having, all those resources are being managed by operating system. Now in today's systems, there can be multiple processes. We encounter these examples in most of the scenarios that processes can execute concurrently, or maybe we can say processes are executing in parallel. So now when there are parallel process, I can say the designation of operating system becomes more kind of important, or the task or the role of operating system becomes more prominent, because the synchronization of resources has to be done, and this will be done only by the operating system. And this resource synchronization, that means all these processes which are concurrently executing, or execution in parallel is going on for all those processes. So synchronization of resources in between these processes is usually not a problem, unless some simultaneously occurring processes use a common resource. So for example, there are two processes, let's say P1 and P2, and then P1 and P2 on the same point of time, they are asking for a common resource, or they are trying to use a common resource. Unless this is not a scenario, the resource synchronization is a simple job to be done kind of by the operating system. So as far as synchronization, or the concept of synchronization is concerned, the types of processes in this view will be of two types. One is an independent process, another one is an cooperative process. So independent process is something, as the name indicates, it is independent. That means whatever independent processes we are having, the execution of one process does not affect the execution of the other processes. As far as cooperative process, which is the next category, is concerned, a process that is going to be affected by other processes executing in the system are known as cooperative processes. So two type of processes, one is independent, another one is cooperative. And the process synchronization problem, that means the processes which are executing in parallel are trying to use a particular resource simultaneously. This kind of process synchronization problem arises in the case of cooperative processes, just because independent processes has nothing to do with each other, while these cooperative processes are in cooperation with each other. That means they are getting affected by the execution of one another. So this process synchronization problem arises in the case of cooperative processes, also because the resources are shared in a cooperative processes, and independent processes are not going to share the resources. So what kind of example we can put in here in order to show that these cooperating processes are sharing the resources. So for example, your cooperating processes can either directly share a logical address space, that is they can share both the data as well as the code, or they are allowed to share the data only through files or messages. So there can be both the things. One is they share a common address space, and whatever data and code is available within that common address space, that is being used by one or more than one processes, and that too simultaneously. Or these processes are allowed to share the data only through files or messages. Now direct sharing of logical spaces is something that a logical address space is being shared by two or more than two processes. This is exactly an kind of, we can say, execution scenario of threads. So direct sharing of logical spaces can be achieved through threads, and that's why this topic of process synchronization is very well in sync with, or very well connected with, these threads, because the moment we are talking about threads, that means we are talking about sharing of some logical spaces, and whenever we are talking about sharing of logical spaces, the processes will be obviously cooperating processes, and in case of cooperating processes, we have to look into the problem or the process of synchronization, I can say. So yes, so after understanding this, that what actually this process synchronization and what kind of scenario we are talking about, and there will be kind of two types of processes, one is cooperative, another one is independent. Let us try to see with the help of an example that what is the need of process synchronization. Now, while simultaneous execution, or while at the time of parallel execution, concurrent access to shared data may result in data inconsistency. So, for example, let us say at a particular point of time, there is a process P1 through which a transaction is going on, and that transaction is is about the depositing some amount of money into an account. So definitely account is going to be credited, and the amount the money will be plus. On the similar time, let's say there is a process P2 which is trying to access the balance of that particular amount. So what will happen? So on one side, one process is trying to update that balance, and another process is trying to read that balance. So either that balance will be if given before the we can say before the updation, that balance we can say is not the consistent data, because just after a particular instance, what your process P1 which was depositing money into the bank account will see is going to be a different balance than what process P2 has taken out. So basically what is happening here is a shared data, which is account balance, is being accessed by more than one process concurrently, that means at the similar time, simultaneously we can say, and this is going to result in the inconsistency of data. And this inconsistency of data is going to occur when various processes share a common resource in a system. So inconsistency, when we talk about, is one state is given to one process, another state is given to another process. That means the data, the common data which these processes are using are not they are having different copies of that particular common data. So this is what your inconsistency of data is being called. So all the processes accessing that particular data on a simultaneous time are having different versions of data. So this is what you called as inconsistency. So inconsistency of data is going to occur when these processes share a common resource in a system, as we have given the example of a bank account. So basically what was happening here is a process P1 is trying to read the data which is present in a memory location, while another process P2 is trying to change that particular data present at the same location at the same time. So there is a high chance that the data read by the process 1 is going to be incorrect, and hence there is a data inconsistency. So this is what the problem where the process synchronization leads up to some inconsistent data. So this can be understood with the help of a figure which is available on the screen. So here are three processes: process 1, process 2 and process 3, and all these three processes are actually accessing one particular data which is present inside a memory location, and that memory location is being shared between process 1, process 2 and process 3. Now see, interestingly what is happening here is process 1 is reading the shared memory or reading that particular location of the memory. Process 3 is also in a read mode, that means it is also accessing the data in a read mode, while process 2 is in the mode of updation, that means it is updating the data, it is writing something on the data. So process 2 is writing on the data while process 1 and process 3 are reading that particular data. That means there is going to be an inconsistency here, that process 1 and process 2 may read some else whatever the different version of that particular data than what process 2 is having. So this is actually a very common scenario when we talk about the process synchronization. So with this we have we are convinced that yes, there is a need of this kind of maintaining the consistency in such scenarios whenever process synchronization is required. So process synchronization is actually an important topic when we talk about the process management under the task of operating system, because without synchronization process management cannot be completed in a graceful manner or in a non-chaotic manner. So with this establishment of process, what actually the process synchronization is and what is the need of process synchronization. In a nutshell we can say the procedure which is involved in preserving the appropriate order of execution of cooperative processes is known as process synchronization. So I repeat, the procedure or the process involved in preserving the appropriate order of execution of cooperative processes is known as process synchronization. Now what kind of synchronization mechanism or what kind of solutions we are talking about, which we will be taking under consideration in order to maintain the synchronization of processes, or in order to synchronize the process, what various synchronization mechanism can be used. So there are four synchronization mechanisms which are very popular when we talk about the process synchronization, and the list is like this. The first is a semaphore, the second is a mutex, the third one is a synchronization hardware, and the fourth one is known as Peterson solution. So all these fours are actually the synchronization mechanism we can say, or the solutions when a synchronization of processes is required, and these synchronizations are semaphores, mutex, synchronization hardware and Peterson solution. And yes, we will be looking into all these four solutions into very into detail in our upcoming lectures. But before going into the strategy of the solutions, let us try to see that whenever a process or whenever a program is getting executed, or whenever a process is being submitted to operating system, what all sections or what all elements this program or this process this process contains as far as the synchronization is concerned. So we will be looking into sections of a program from the point of view of synchronization or process synchronization mechanism. So there will be all in all the four sections of the program as far as synchronization mechanism is concerned, and these four sections are: first is entry section, second one is critical section, third one is exit section, and the fourth one is remainder section. So four sections in all: entry section, critical section, exit section and remainder section. Now let us try to understand that what all these four sections actually mean. So entry section of a process or entry section of a program, as the name indicates, it decides the entry of a process. That means the process which process is going to get entry, that's the that is basically the entry section of the program, which is the deciding factor for the entry of a process. Next comes the critical section. Now, as far as process synchronization is concerned, this is very important, and this is, we can say, it's a very important element as far as the solutions to the synchronization or the implementation to the solution of synchronization is concerned. So, critical section is the section which allows and makes sure that only one process is modifying the shared data, and this is the key here. Critical section, I repeat, critical section allows and makes sure that only one process is modifying the shared data, and this is what is actually, we can say, is the solution or the root cause of our process synchronization, through which we can implement the synchronization of various processes smoothly. That means one particular element of the program is given a responsibility of ensuring that the shared data will be used by one process at a time, or the shared data will be modified by only one process at a time. This property is being ensured by our critical section, and this critical section is nothing but an important element or section of a program. So, two sections we have seen, one is entry section and another one is a critical section. Coming to the third section, which is the exit section. So, exit section is about handling the entry of other processes in the shared data after the execution of one process. That means one process has taken its turn, we can say, in a way, and it has got the access to the shared data, and now that one process which is which has taken the access, used the shared data, now in a process of exiting, and the another process which is which are lined up or which were there in the queue for the use of this shared resource are trying to get entry. So, this is being kind of managed by exit section, that is the entry of other processes in the shared data after the execution of one process is handled by the exit section. So, this is what the importance of exit section is, and the fourth one is a remainder section. So, three sections we have seen: entry section, then the important one critical section, then we have seen the exit section, and the remaining part of the code which is not categorized either as the entry section or as the critical section or as the exit section is we can say is contained in the remainder section. So, basically now your process is divided into, we can say, four sections or four elements. One is the entry section, which is deciding the entry of a process. Second one is the critical section. This critical section is allowing and making sure that only one process is modifying the shared data. So, here is the key to the synchronization. Then we have the next section, which is the exit section, and this exit section is kind of, we can say, handling the exit of one process from the shared data, and entry of another onto the shared data is being handled by exit section. And the fourth section, which is not being categorized as either of the three, neither as the exit section nor as the remainder or critical or the entry section, will go under the remainder section. The remaining part of the code which is not categorized as above is contained in the remainder section. Now, if you want, we can see one figure here in order to understand the whole flow of these elements of the program. So, this is shown in the form of a pseudocode. So, here is a process which is giving you one entry section, then there is a critical section between entry and exit, and after exit section there is a remainder section, and this whole process will go while, we can say while true, that means while your process is going on, this whole scenario is getting repeated. So we have this, we have shown this within a do while loop, as I have told you that in the format of a pseudo code we are showing this. So within the do we have one entry section, another section as the critical section, third section exit section, and the remainder section. So entry section will help in taking the entry. Critical section is going to ensure that only one particular process will be entering inside the critical section and executing the in the critical section, and meanwhile one process is serving in the critical section, no other process is allowed to get inside the critical section, and followed by the critical section when one process is coming out, after sharing of after usage of that shared resource is the exit section, and whatever sections are left which are not being categorized as entry section or the critical section or the exit section comes under remainder section, and this will go on for till the processes are getting executed. So we have written it inside a do while loop, and the test condition of the do while loop is while true. So while 1 we can say, or while everything is going on. So these are the 4 elements of the we can say our program. Now more than one process is either running the same code or modifying the same memory or any shared data. Now this is what the problem was. The problem was a shared data or kind of shared logical space memory, we can say, which is going to contain code as well as data both. So more than one processes are trying to access that simultaneously, and that too we can say they are trying to modify or they are trying to update. If there are two processes, let us say P1 and P2, and both are trying to read that particular shared data, there is no problem. But if one of them is trying to modify the data, then yes, there is going to be a, kind of a we can say inconsistency or a conflict. So now when there are more than one processes which are running the same code or modifying the same memory or maybe same shared data, there is going to be a risk that the result or the value of the shared data may be incorrect, because all the processes are trying to access and modify that shared resource. And now whatever processes are trying to execute or trying to modify that particular data, they are actually we can say entering in a race to prove that the result or the version given by that particular process is correct. So I am repeating this, that is, when there are more than one processes contesting for the modification of a particular shared data or the memory, there is a risk that the result or the value of the shared data may be incorrect, because all the processes are trying to access and modify this shared resource. That means all the processes are in a race in order to prove or in order to say that their result is correct, and this condition we call is the race condition. So basically why the term race is being used here is many processes are using the same data, and the result of or the final version of that data or the results of the processes will depend on the order of the execution of various processes. So whatever processes, let us say P1, P2 and P3. Now let us say one you have one particular amount or one particular, let us say kind of figure. One process is trying to multiply, another process is trying to kind of add something into that process, add something into that amount, and the third one process is trying to subtract something from that amount. So final result, what final figure of that amount will depend on the order of execution of these processes, because if multiplication is going to happen earlier, the process will be, the result will be different, or if there is kind of the subtraction is going to happen on happen as the first transaction, it is going to yield a different result. So what is happening here actually all the processes are trying to prove that the result generated by them is correct, and such a situation is called the race condition. So race condition is basically, it is a situation that is going to arise when a process is in the critical section, or when the critical section is getting executed. So the race condition is a situation that can arise within the critical section, because in critical section a race condition occurs when the end result of multiple thread execution varies depending upon the sequence in which the threads execute. As I have given you the example of 3 processes, one trying to multiply, another one trying to add, and third one trying to subtract some data. So in the critical section, race condition is most likely to happen, because what is happening here is end results of multiple threads or end results of multiple process execution varies depending on the sequence in which the threads execute, and each and every process is trying to prove or trying to say that the result generated by them is correct. So that is what the race condition is, and definitely we will be looking into the solution, that how are we going to kind of maintain, or how are we going to handle this race situation through operating system. So in this lecture, let us summarize that we have started with what is process synchronization, that we have seen what is the need of process synchronization, and after establishing the need of process synchronization with the help of bank account example, we have seen what are the kind of elements or sections of a program when we talk about the synchronization mechanism, and within that, after going through the 4 parts, which are entry section, critical section, exit section, and remainder section, we have also seen that what is your race condition, and what are the likely scenarios in which your race condition may arise. So that is what the critical section in which the race condition may arise, and we have also seen what is a race condition. So here is a list of references which is being used for the preparation of this lecture. Thank you for the patient hearing. Hope you have enjoyed the lecture.